There are 18 volcanoes in the United States that geologists consider a very high threat. That is not an opinion. It is a formal classification, a designation earned through a cold calculus of explosive potential and human proximity. These are not dormant relics. They are active systems, measured daily, their internal pressures monitored by a web of sensors listening for the first sign of a shift. And the one that dominates the headlines, the supervolcano that lives in the public imagination, is not even in the top 20. No, the real danger is hiding in plain sight. It is a list, a government document published on October 22, 2018, that ranks 161 volcanoes by their potential for destruction, and its conclusions are deeply unsettling. Tell us in the comments which volcano you think holds the #1 spot. The official answer is not what you expect. The truth is, an astonishing number of people who find this information critical, people who watch these briefings to the end, forget to subscribe. If you value this analysis, hitting that button is the single most important thing you can do. It is a small click that makes a huge difference, and it ensures you get the next report without fail. So, do it now. Let's begin. The United States Geological Survey does not deal in speculation. It deals in data. Numbers. A complex 24-factor matrix that balances two simple variables, hazard and exposure. The result is the National Volcanic Threat Assessment. It is not a prediction of when. It is a calculation of how bad. It is a guide to the places where the ground beneath our feet is not as solid as we believe. And the first thing this list forces us to do is confront a myth. Yellowstone National Park. The caldera. The media's favorite apocalypse. The USGS ranks it at number 21. It sits firmly in the high threat category, but safely outside the top 18 very high threat volcanoes that keep geologists awake at night. This is not a mistake. Dr. Michael Poland, the scientist in charge of the Yellowstone Volcano Observatory, has spent a career explaining why. The threat ranking is not about the size of the biggest possible bang. It is about the probability and the proximity of danger. Yellowstone's last magmatic eruption was 70,000 years ago. Its location in the remote corner of Wyoming, Montana, and Idaho means the immediate population exposure is relatively low. The millions of people are not there. Even the recent earthquake swarms, the kind that light up internet forums, like the 3 small clusters in June of 2026, are, in the words of the USGS itself, typical background activity. Not a prelude, not a warning, just the normal heartbeat of a massive but deeply slumbering system. So if Yellowstone is not the monster at the door, then what is? What replaces it on this list of imminent threats? The answer begins 1,300 miles away in Northern California. Number 5. Mount Shasta. A magnificent, sprawling stratovolcano that seems to float above the landscape. It is the quiet giant of the Cascades, a peak that has not had a significant magmatic eruption in over 3,000 years. And yet, it ranks as a very high threat, watched constantly by the California Volcano Observatory, a post now held by Philip Dawson since his appointment in January 2025. Why? Because Shasta's danger is not just about eruption, it is about collapse. Between 300,000 and 500,000 years ago, an ancestral version of the mountain you see today failed catastrophically. The entire north side of the volcano gave way, creating one of the largest landslides ever documented on Earth. A river of rock and debris that covered 170 square miles, reshaping the landscape forever. The modern cone has since grown back on top of that scar. The potential for a similar collapse, triggered by a small eruption or even just a major earthquake, is a scenario that is hard to model but impossible to ignore. Its immense size and proximity to communities and vital infrastructure put it squarely on the list. It is a threat defined not by frequency, but by sheer scale. From California, the threat matrix moves us north, far north, to a place where the proximity danger is not to cities, but to the arteries of global commerce. Number 4. Redoubt Volcano, Alaska. A 10,197-foot stratovolcano on the west side of Cook Inlet. On the ground, it is a remote and unpopulated wilderness. In the air, it is a nightmare. Redoubt sits directly under some of the busiest air traffic corridors in the world. Anchorage is one of the planet's largest cargo hubs. Thousands of flights a day connect Asia to North America, and they fly directly past this mountain. We know exactly what can happen because it already has. In 1989, a KLM Boeing 747, Flight 867, flew into an ash cloud from an erupting redoubt. The fine, abrasive particles of volcanic glass were invisible to radar. They were ingested by the engines, where the intense heat melted the silica. The molten glass then fused to the turbine blades, starving the engines of air. All four of them flamed out. The jumbo jet, with 245 people on board, became a glider, falling more than 2 miles in 5 minutes through a black and suffocating sky. The crew, through sheer miracle and skill, managed to restart the engines just moments before impact. The Alaska Volcano Observatory, under scientist in charge Matt Haney, exists to prevent that from happening again. Redoubt is number 4, not because it could wipe out a city, but because it could knock planes out of the sky. We're now 2 volcanoes into the top 5, and the picture of what threat means starts to sharpen. It's not just about population, it's about infrastructure. It's about the systems we depend on. Do these rankings make sense to you yet? Let us know in the comments. From the remote skies of Alaska, we return to the most densely populated corner of the American volcanic landscape, the state of Washington, where 2 titans of the Cascade Range sit like twin-time bombs. Number 3. Mount Rainier. At 14,409 feet, it is the highest peak in the Cascades, an icon looming over the Seattle-Tacoma metropolitan area. And it is, according to the USGS, the 3rd most dangerous volcano in the United States. Again, it is not the lava that worries scientists, it is the ice. Mount Rainier holds 25 major glaciers, a frozen reservoir containing more snow and ice than all other Cascade volcanoes combined. A small eruption, or even just a period of intense heat and seismic shaking, could melt a fraction of that ice in an instant. The result is not a flood, it is a lahar. A volcanic mudflow with the consistency of wet concrete, thick with rock and debris, moving at highway speeds. It would not flow like water, it would surge like a solid wave, hundreds of feet high, scouring valleys clean and burying everything in its path. The USGS estimates that some lahars could reach the heavily populated suburbs of Puget Sound in as little as 30 minutes. This is not a hypothetical. The towns of Orting, Sumner, and Puyallup are built on top of the hardened deposits of ancient lahars from Rainier. They exist on borrowed ground. Angie Diefenbach, a US geologist, noted in 2018 that as many as 300,000 people live in this downstream hazard zone. They go to work, they go to school, they sleep in the direct path of a potential catastrophe. And Rainier is not quiet. Over 4 days in July of 2025, it experienced its largest earthquake swarm in recorded history, a frenzy of over 1,350 microquakes deep beneath the summit. Then, on July 3, 2026, just days ago, sensors picked up a minor debris flow in Tahoma Creek, likely a glacial outburst. The mountain is active. It is shifting. The Cascades Volcano Observatory, led by Dr. John Major and Dr. Seth Moran, watches every tremor, knowing that the stakes are measured in minutes and human lives. This brings us to the volcano that seared its name into the American consciousness, a name that for decades has been synonymous with volcanic devastation. Number 2. Mount St. Helens. Before 832 and on May 18, 1980, it was a near-perfect conical peak, standing 9,677 feet tall. By 8:33 am, it was an open crater, 1,000 feet shorter, and the center of a lateral blast that flattened 230 square miles of dense forest. It killed 57 people. It sent a plume of ash 15 miles into the stratosphere, an ash that would circle the globe. For many, the 1980 eruption is the only frame of reference for what an American volcano can do. The reason it remains at number 2 on the threat list is simple. It has proven its capability and its willingness. The 1980 eruption was not an end. It was an event in a cycle. The system is recharging. A new lava dome is growing inside the crater. The volcano is rebuilding itself from the inside out. The USGS monitors it with an intensity born from memory. They know how quickly it can move from unrest to eruption. They know its preference for explosive, violent behavior. Its threat score is a direct reflection of its history, a history written in ash and devastation, and its proximity to the growing populations of the Pacific Northwest. It is the known killer, the monster we have already met. If you have family or friends living anywhere in Washington, Oregon, or Northern California, they need to understand this landscape. Share this video. Hit the like button so this information reaches more people who live in the shadow of these mountains, because awareness is the first line of defense. And so, we arrive at the top of the list. Number 1. If it is not Yellowstone, and it is not the proven killer Mount St. Helens, or the lahar time bomb of Mount Rainier, then what could possibly be more dangerous? The answer is a volcano famous for its gentleness, a volcano known for slow, picturesque lava flows that people can literally walk up to. A tourist destination. Number 1. Kilauea, on the Big Island of Hawaii. The ranking seems impossible. It defies every popular image of volcanic danger. But it is the cold, logical endpoint of the USGS threat assessment. The ranking, lead author John Ewart explained, is not a list of which volcano will erupt next. It is a way to focus resources where they can be most effective. And Kilauea is the perfect storm of hazard and exposure. First, the hazard. The perception of gentle lava is a dangerous oversimplification. Kilauea is a shield volcano, yes, but it is fully capable of explosive eruptions. Its summit crater, Halama-Umayu, has a history of violent, ash-driven events that pose a severe risk to aviation. The slow-moving lava flows are themselves incredibly destructive, as the 2018 Leilani Estates eruption proved, burying entire neighborhoods and vaporizing hundreds of homes. And the volcano is not just capable, it is active, right now. As of this briefing on July 9, 2026, Kilauea is in the middle of an aggressive eruptive episode. The activity that started in the Halama-Umayu crater in late 2024 is ongoing. On June 27, 2026, the eruption reached what the Hawaiian Volcano Observatory is calling Episode 50, shooting spectacular lava fountains 1,000 feet into the air. Dr. Ken Hahn and his team at HFO are tracking it minute by minute. Their latest forecast predicts Episode 51 is likely to begin between July 11th and July 15th. This is not ancient history. This is happening this week. But the real reason Kilauea is number 1 is the second part of the equation. Exposure. Unlike the remote peaks of the Cascades or Alaska, people have built their lives directly on the slopes of Kilauea. There is extensive suburban development, roads, schools, and critical infrastructure located squarely within its hazard zones. There is no buffer. The volcano and the community are one and the same. When Kilauea erupts, it erupts through someone's backyard. That combination of relentless, ongoing activity and extreme human proximity is what catapults it to the top of the list. A slow-motion disaster is still a disaster, especially when your home is in its path. This list, this ranking from 1 to 161, is more than just an academic exercise. It is the foundation for a national defense system against the Earth itself. The 2018 threat assessment directly led to Congress authorizing the National Volcano Early Warning and Monitoring System, or NVUS, in March of 2019. This is the government formally recognizing the scale of the threat and allocating the resources to meet it. It is an admission that these volcanoes are not abstract risks, but quantifiable dangers that require a coordinated national response. The system is a network of 5 specialized observatories: the Hawaiian Volcano Observatory, the Cascades Volcano Observatory, the Alaska Volcano Observatory, the California Volcano Observatory, and the Yellowstone Volcano Observatory. Each one is a nerve center, a fusion of geologists, geophysicists, and computer scientists, all focused on interpreting the subtle language of their respective volcanic regions. They deploy an arsenal of tools: GPS stations that measure ground inflation to the millimeter, seismometers that can distinguish a tectonic earthquake from the tremor of moving magma, gas sensors sniffing the air for changes in sulfur dioxide, thermal cameras that map heat flow invisible to the naked eye. This is a silent, constant battle of data against geology. Every data point is a piece of a puzzle. Is the ground swelling because magma is rising, or is it a seasonal change from groundwater? Is that gas emission a sign of a new vent opening or a temporary blockage being cleared? The scientists in these observatories, the Michael Pollans, the Seth Morans, the Ken Hans, are not just academics. They are frontline intelligence officers, and their enemy is a force of unimaginable power that gives very few clues about its intentions. Their job is to find the signal in the noise, to provide the warning that gives communities hours or days to evacuate instead of minutes or seconds. What is it they are looking for? The signs of an awakening are subtle at first. A deep, low-frequency hum, known as harmonic tremor, can signal magma moving through underground conduits. A sudden change in the chemical composition of gases venting from a fumarole can indicate that fresh, hotter magma is approaching the surface. A swarm of small, shallow earthquakes clustered directly beneath the summit can mean rock is fracturing as the pressure from below increases. None of these signs alone is a guarantee of eruption, but when they happen together, when they accelerate, they form a pattern. A crescendo of signals that tells the observatory a system is moving from repose towards failure. And the nature of that failure is radically different from volcano to volcano. Compare the two most famous American eruptions of the last 50 years. Mount St. Helens in 1980 and Kilauea's Lower Puna eruption in 2018. They were both catastrophes, but they were catastrophes of different kinds. St. Helens was a release of pressure, a violent, explosive event that lasted hours but whose main destructive phase was over in minutes. It was a geological detonation. Kilauea was the opposite. It was a failure of containment. A slow, relentless bleed of magma that lasted for months. It was not a single moment of destruction, but a rolling disaster that consumed a new piece of a neighborhood day after day. A lava flow in Hawaii gives you time to evacuate. It gives you time to watch your house burn. The USGS has to plan for both. They need monitoring systems that can detect the rapid pressure buildup of a St. Helens and the subtle plumbing changes of a Kilauea. They need hazard maps for explosive blasts and ashfall, and separate maps for slow-moving lava flows. They need to communicate risks that can kill you in an instant, and risks that will take your home over the course of a summer. This complexity is why the single, simple image of a volcano erupting is so misleading. There is no single type of volcanic danger. A second time, I know. But it's crucial. An incredible number of people who watch this far, who absorb all this detail, are still not subscribed. If you found this information valuable, if it has changed how you see the landscape, then lock in the channel. It is the only way to be sure you don't miss the next update. And with 161 active volcanoes, there will always be a next update. Let's go deeper into the specific threats, the unseen dangers that give these volcanoes their rank. Mount Rainier's lahars are a prime example. Geologists have mapped the deposits of at least 60 major lahars from Rainier over the last 10,000 years. The mountain produces them regularly on geological timescales. The electron mudflow, which occurred about 500 years ago, was one of the largest. A colossal wave that traveled all the way to the Puget Sound lowland, burying the land where the Port of Tacoma now stands. The town of Orting, with a population of 8,000 people, sits entirely on top of the deposits from this single mudflow. It has a lahar siren system, a network of speakers designed to give residents a 40-minute warning. That is the margin of safety. 40 minutes to get to high ground before a wall of rock, ice, and mud moving at 50 miles per hour arrives. Then there is the aviation threat, personified by Redoubt, but common to many volcanoes. What precisely does volcanic ash do to a jet engine? The ash is not like soot from a fire. It is pulverized rock and glass when it enters the combustion chamber of a jet engine, which operates at temperatures hot enough to melt steel. The ash itself melts. This molten silica then flows to the cooler parts of the engine, the turbine blades at the rear. It resolidifies there, coating the precisely engineered blades with a layer of glass. This coating disrupts the airflow, causing the engine to surge and stall. In the case of KLM Flight 867, it choked all 4 engines into silence. The problem is so severe that global aviation authorities now have volcanic ash advisory centers, or VAACs, whose sole job is to track ash clouds and route thousands of flights around them. A major eruption from Rainier or Shasta would not just threaten the ground, it would shut down air travel across the entire West Coast. This framework, this entire system of threat assessment and monitoring, is relatively new. The first list was published in 2005. The 2018 update was a refinement, incorporating better data, new geological models, and the lessons learned from recent eruptions around the world. The positions on the list are not permanent. Volcanoes can move up or down the ranking as conditions change. A long dormant volcano showing new signs of life might see its threat score increase. A city expanding towards the base of a mountain adds to the exposure variable, pushing that volcano higher on the list even if the mountain itself has not changed. The list is not a static document. It is a live reflection of the dynamic relationship between our civilization and the planet's powerful, creative, and destructive geology. It tells a story not just about mountains, but about us, about where we choose to build, what risks we are willing to accept, how much we are willing to invest to protect ourselves from a threat that is both ancient and ever-present. The work is endless. The monitoring never stops. The data flows in from hundreds of sensors, 24 hours a day, 7 days a week. At the observatories, scientists stare at screens, looking for the flicker in the data that could mean everything. The ground beneath Mount Rainier swelling by another millimeter, the sulfur dioxide levels over Kilauea spiking, a deep tremor near Mount Shasta that doesn't match the signature of a normal earthquake. The threat list is not a forecast. It is not an itinerary for disaster. It is a mirror. It forces us to look at the landscape not just for its beauty, but for its power. And it shows us not what the Earth might do one day, but what we stand to lose when it does. The ground is not as solid as we thought.